Yeah. So yeah, this is the last one. I know, like, I'm supposed to walk over and get some food, so I'll try to be quick. But yeah, my name is Aaron Radke. My curriculum vitae is there, and Twitter, and you can look at this whole presentation at the bottom link. It's just a HTML web page. I scroll through. I'm trying something new. So the background and motivation of this is, let's see, it's not fit. So I come from like the scientific community more than like computer science, but everybody's using programming tools, and I mean that's like the tool. It's like a pencil now. And even my 6-year-old is like came home one day and he was like, "Dad, everybody can code except for me." And I was like, he was like, "I can't even type." That's what my son was saying. So we're going through the Haskell for introduction, and he loved the Why Pigs Can't Fly, or no, yeah, Why Pigs Can't Fly, the type theory chapter. So anyways, from the scientific engineering perspective, they usually have like these weak languages. And you guys will laugh at Java, but like they don't even have types. And MATLAB is the king, and Python, and then it's like that's the prototype phase, and then there's like the implementation phase, like porting it over, or somebody else is doing that, and then visualization tools of either your implementation results or your prototype, or so it's a world that like I've been in, and I've been increasingly like for the past 15 years like interested in like being able to do it like syntactically clear and having all the help you get. And I bounced around a lot from these different visualization tools. Like processing was an amazing tool, like actually out of MIT's Media Lab on Java, and then like I wanted easier programming, so there was something called Ruby processing that ran on there, and then like but it was too slow. And so I found Scala by Twitter saying they were using Ruby and it was too slow. And then I found Nathan Hamblin did the SPDE, which was the Scala processing developing environment on top of processing. And then there's this like other vector of like visualization is D3, and that was like really powerful concepts. So that's kind of the world I was. And so slowly I've been like testing, building my own, instead of using MATLAB, prototyping in Scala and visualizing there. And the interesting thing here is like these ors become ands, and like I demonstrate something in an algorithm and like, actually I probably didn't say that. I'm in like engineering of like automated unmanned vehicles and underwater and air, and like you show something, and now that implementation is fast enough to run in like a real time. So like the same prototype I use is now like being used under the water, and so then like all my libraries had to like I got to publish it. It's not just like my engineering notebook. So this is like a talk about something that I think is maybe interesting about my libraries from from a type class perspective. So, and in the meeting yesterday, actually I saw this tweet. I don't know if anybody knows who this was from. I couldn't remember who it was, but it was like everybody would love to have a language that's as concise as Python, and the speed of C, and the ecosystem of Java, and rich types like Haskell. And Scala kind of has a blend of these, not perfect in everything, but like that's what we get. And so, and that's, I think this is kind of the reason a lot of us love it too. And in one of the unconference meetings, there was a big data discussion. And the question was like, why are people, data scientists, using Python so much instead of Scala? And one of the big answers that they commonly said was like, it wasn't necessarily, they were saying like, oh, can't you prove to them and show them that it's faster or more concise and type safe, and they agree. But like the big thing they said was that the workflow of using Python to try something and visualize it, then those libraries aren't there. So it's another argument of saying, like, I think in the Scala world, like, we can provide some of these, we just don't have the libraries there. So here's the state of the Scala visualization. You guys might know some other things. This is kind of what I was aware of. But I think that Scala can offer, like, this is kind of the argument of my talk, is that the semantics and the types that you get can actually be making it more concise and usable. Like, I really like a lot of the John Preddy's work where, like, he hides a lot of the detail and uses it, and then, but at the front end use, it's very concise and simple because a lot of the work is behind. So it's kind of like, can we do that for the visualization world? So here's kind of the state of the tools. Oh, I didn't start it. Let's see. So there's these Java wrappers. I talked about the processing wrapper, and then there's wrappers around JFree graph. But that's on the Java side. And now that D3 is kind of taken over the visualization world, and like, but that's in the JavaScript. So if you're running a big data thing on Spark, you're actually getting data, you're piping it through some JSON, putting it into the browser, and you can't like plot like millions of data points that like interactively explore things. And then there's some interesting, there's actually a Scala wrapper around Vega, which itself is a wrapper around D3, but it has some really interesting direct Scala, composable types. And then there's some other libraries. And last year I saw Doodle from Noel Welsh. Is like kind of the first time I saw a first-class Scala library inside. So you can actually get Scala types that are shapes and can compose them together to build up visualizations. And then I saw that one of the talks I voted for was something on evil plot. That was something a combinator visualization. I'd love to talk to you about it. I'm really, this whole area I'm really curious about. So, and then the question mark is what else? So I think, there's a lot of stuff that I built up over time, but this is just a slice of type classes. So we get a lot of this stuff that I think would be useful for visualization purposes. We can have alternate compiler rendering targets. If we have one representation that's just pure Scala, it could compile to the JavaScript environment or to native, which would allow you to do OpenGL visualizations or Canvas reservations, or directly in the Java world of. And then also we could plot. So when you visualize something, you think it's always just a double, but here you could bring your own types. Like if you have your own types, and you have some type classes that provide your visuals, if you implement those simple methods to make instances, you could automatically get everything from some library. And then alternative algorithm implementations, like in the back end, I have like different fitter functions, and I can call them out. Like have one code that's already compiled and just say, hey, use this other implementation instead. And the type class gives you all this. And reduce boilerplate, I think this is another thing, like cleverly having your implicits in the background can pull out the ones that are needed instead of you having to manually type them. And then type checking also is like instead of relying on double as the universal plot function. So how does this all do? So here's a real quick, I think I'm just going to spin through this really quick. Everybody knows type classes, but for those who don't, like, here's one little perspective of them. And I just kind of facetiously was saying, like, hey, this is not a type class. And even though this is what's always shown as, but this is, I was like, when I was first learning, it was like, what is this type class? This is ridiculous. There's yeah, that's fancy stuff you can do, but I don't see the point. So like, I was like, this is just an abstract class. What's the deal here? And I was like, there's an implementation, the instance of it. And I was like, this is not a type class. This is just an instance of your abstract class. Like, I don't get what's the deal. And so you know, we normally talk about the syntax of the type class as just the extra stuff to make it work. But I kind of argue that like that's really the essence of it, because it's got all the parts. It's got the objects, it's got the definition that, hey, there is an implicit somewhere, and it tells what the type is. So then an example, and so I have, this is the definition, the instance, and the syntax, and the example is the same pattern. I'm going to go through each of the type classes that I have. And so, when I was learning this, it was like, oh yeah, it's cool, implicit trick. But why can't you just do show anything? I can just do that. I can even do it generically. But it's the reason why is this is the only thing. The string is the only thing you can do this to, because Java has generically everything as a string. But you can't change the implementation. So this is the power of that. So you have the same show method, and you have an implicit object, you know, implementing your type class here. So this is the type class, and this is how I'm using it. There's much more power and use of it. But like just this simple idea gives you all those lists of features that I was like, hey, we can use this for visualization. And so that's why they're not just a simple single element. They're like a conceptual use of multiple pieces. So anybody who's new to this is like, give type classes a go. Don't be like, this is complex type theory. It's a very simple pattern that's powerful. And especially in Scala, because I don't even think in Haskell you can have that like implicit resolution of, hey, use my other one instead of the default. And I heard something, or Radke say something like Scala is implicit. So I don't know if that's true, or I thought I remember hearing something like that. So here are some of the type classes that I kind of fell into. It's kind of evolved and you discover these things. So like there's the main purposes of the visualization is rendering, like drawing your shapes to the screen, and then mapping, because you get some data and you want to map it to some pixels. And then formatting, showing your data as text if you need to label it, and then different algorithms. And then there's also, I have a bunch of different types that are not type classes themselves, but they like support, I have default instances for these types, or these types of data so that they can be used for the visualization. Targeting. So here's an example of the render. So it's real simple. There's a lot much more hidden under here for different shapes. But just the idea that you have this thing, and in the rendering context, they're all mutable. So like hopefully by using this, you can hide all that mutable, all the mutable drawing contexts. And this is a kind of a state of what, so originally I was using processing to generate these guys, but then recently implemented the draw context within Java FX, and now it's like completely pure Scala. And then I was able to compile to the JVM, Scala.js, and Scala native. And I still would like to implement the draw context for these guys, but it's like, oh, and this is the use in Doodle. The same kind of type class was used to have these different rendering contexts. But kind of the unique thing that I'm thinking about is using the type class to do this automatic scaling. And so here, this is kind of from D3. I feel like this is like a key concept in D3. It provides all these scales, these mechanisms of scales that like allow you to map data to pixels. And sometimes if you move your mouse, you can go from your pixels back to what data it was that generated that. And so these few methods are, the map. And this invert is only if you're going to do if you need to go backwards. And so I have a different scale if you only need to go one way. But so here's an example. So flipping it around and starting the example first. So to simply say scale, and then you can just have a mapping of 2 is the red and 10 is the orange. And behind the scenes, the implicits that are matched know how to linearly interpolate these things. So as an example from processing, if you were going to do this, you'd have to write out a map of 5. If you want to look up, this is supposed to be lookup age 5. So if you're going to look up 5 within here, you have to map it to there, and then you got to find out a specific function that does that linear interpolation. But this will look up. So if you have all your functions like this, you really just are able to have really concise statements, and I think it's a little more beautiful. But the syntax of it is like kind of scary looking at first, but it's powerful in that if the type of values you have in there are of this type class boundable, and then the boundable is implemented very simply, then it can do all this mapping and looking up. So, and I also went through the D3 scale. It's kind of his documentation. Mike Bostak's really great on these algorithms, but there's a whole bunch of different types of scales, like tried to implement within the same type class that are useful. And so, but this bound is something that is not in D3 that I found very useful. It's kind of like Spire's interval, where it's just a min and a max, and then it can be scaled, and you can step into it. And so, I think time is up here, so I'll just go through this really quick. I've got this bound. This bound is the thing that, like, when you do a scale, it automatically can derive the linear interpolations between these guys, and also log interpolations. And another major tool is using something simpler to cats. So if you have your label, instead of having to say like, oh, annotate this data with this string and convert it, like if you have something that's a type class like show, which I had called format, then it can automatically, just annotate your data without you having to specify how to show it. And the reason why I have format, there's a little bit more to it when you're visualizing, and that's something called tickable. So this tickable is an additional type class that says, hey, if your data type has this ability to be tickable, which is like you can perform, when you're plotting something and you have a scale of time, you don't want to just step through it exactly. You want to have human representable, like, I want 60 seconds, that's like a minute, or I want to have like 60 minutes, and like all these human, and especially on dates, you want to say like, not 1 day ago, I want it to be, on the first of the month, or so this provide a lot of that functionality. And here's an example, like if you want 5 ticks between this time, there might not be exactly 5 ticks. It'll try to give you the closest number that are on human representable. And this is stuff that's in the D3 library too, but like this is wrapped up. It's wrapped up in a type class. So I'm going to just skip. This time is up, so I'm going to just skip through this real quick. But there's like axes that automatically pull, so you can just do like screen plot, and then it'll plot your types. And so where to find more, you can look at this presentation here. This is available on Maven Central with Apache 2 license, basically because I had, my libraries that have been slowly growing over like 10 years. And like they're like, hey, this is good enough for the production instead of it's fast enough, and oh my goodness, it's got to run somewhere real. So that's why it's published up there. And you can look at it at these links, and the source code for these guys are under these links too, if you want to look at it. I don't know. So time is up there. I don't know if you have any other questions or comments. I'd love to talk to people about visualization in Scala. And yeah.
Can I take a couple questions?
Sure.
Sorry, what is it called?
Oh, what is it called? So it's like, it's kind of like, I call it DRX. It's like it's just a website that I got like many years ago that happened to be three letters. I like searched what's the minimum number. And so like, it was just a DRX library, and core, I have a whole bunch of things, but core is the stuff that's just Scala. And so, And that this versioning's, it's like really, it's my library that I've used just to tinker and play with stuff. Even I've like tinkered and played with like versioning schemes. So this is like some versioning scheme that is, but it's like, oh, it was getting used enough that like I had to publish it so that it can be used at my work. And so I don't know, I kind of like, I'm curious also too, like what components, like as part is to do, like I think maybe separating out some of those pieces would be useful, like, because not everybody wants everything that's in that library. Yeah. So yeah, I just call it the core part of the DRX. Any other questions?